Hello and welcome to Digitalize in Stockholm 2020. I am going to present our project SOS, Smart och Säker, Empowering User Control over Sensitive IoT Data. My name is Fatema Rahimian and I am a researcher at RISE Research Institutes of Sweden. And I collaborate with my colleagues Mozart Valio, Associate Professor at KTH, and Nikolai Palladi, CEO and co-founder of Canarybit. Internet of Things, or IoT, which is becoming very popular these days, refers to various devices and services that are connected to the internet. Some of the examples include different devices at your home, health monitor sensors, surveillance cameras, and safety sensors. For example, there are sensors that can monitor the level of sugar in the blood for diabetic patients. And these sensors can continuously collect this sort of data, which can potentially be very useful and can really save lives. But of course, only if this collected data is analyzed and processed and used to notify the patients themselves or the hospital or emergency services. For example, in case the blood sugar level drops below a threshold or exceeds a threshold. This means that the collected data and measurements must be shared with and processed by other parties, services, or applications. How do we do this? By using an IoT platform, which enables this kind of functionality and bridges the gap between devices and the actual services. An IoT platform is typically a cloud service that monitors and controls these various types of endpoints and data sources, and often via applications and services that are deployed on this platform. So it connects different components and ensures an uninterrupted flow of communication between the devices and services. I will take the example of the diabetic patients again. Imagine that the measurements are sent to a cloud service, and then there are other applications that can read this data, and then they can actually send, for example, the emergency or an ambulance to the patient's home in case the blood sugar level becomes alarming. Or imagine that you have various devices at your home and you can actually connect to the internet via your an application on your phone, and you can remotely control those devices inside your home. But at the same time, that implies that you will lose control over the data and the digital lives. And indeed, IoT platforms come with various security and privacy risks and are subject to different types of attacks. For example, the cloud may be oversharing the data that would breach the privacy, or even share the data with malicious third-party apps that compromise the security. This problem, known as the person in the app attack, enables attackers to disrupt the services and steal or modify the user's data, photo, location, videos, etc. Another type of attack is the attack on the public cloud itself, where basically this is called the person in the cloud attack. And since the cloud has full access to users' data, if it is compromised, then many things can go wrong. And of course, there is a trade-off between convenience and benefits of the IoT apps on one side and the security and privacy on the other side. So the question is, can we build IoT solutions that combine strong data security and privacy with all these benefits that were mentioned? In other words, can we empower users to be in control of their data? And here is where SOS offers some solutions. For example, access control via sandboxing, confidential computing, and homomorphic encryption. And these are different lines of research that we are pursuing. To be more specific, imagine that there is an IoT application where there is a code running inside this application using data from various data sources, applications, sensors, and at the end, it will provide a service to the end user. What we need to make sure is right is basically the safety of the code, environment, and the data at the same time. So we perform security vetting and execution of IoT apps by breaking and tracking the insecure flows. How? By doing static and dynamic code analysis and fine-grained access control via sandboxing. We also need to make sure when this code is deployed in an environment, in a cloud environment, it will be executed in actually a trusted environment. So we do automated orchestration of secure IoT platforms in trusted execution environments. So this means that we will have both software and hardware security components. And on top of this, we need to make sure that the data is not unwillingly revealed to third-party apps, for example. And for that, we suggest fully homomorphic encryption. And now I want to actually zoom into one of our real use cases where we worked on homomorphic encryption. This was a competition named Winter, led by Vinnova, in order to promote diabetes type 1 self-care. So this was based on a cloud service named Hope, which is already developed, and it collects data from patients. If this data is now analyzed, presented, and acted upon, it is, of course, a powerful source of knowledge. On the other hand, if it cannot be shared because of privacy constraints, we waste an opportunity to promote patients' health and well-being. So we want the data to be useful without compromising safety. So the first and main stakeholders of this application are the patients themselves. They are the producers of the data and the consumers of the final results. But these results need to be basically produced by other parties. But we want it to be done safely, and our solution is to enable this safe data sharing and privacy by design by using fully homomorphic encryption. What is that? It's a form of encryption that permits to perform computations directly on the encrypted data without first decrypting it. These resulting computations are then left in basically shared with the third-party apps. They will operate on the encrypted data, and then they will send back the results to the cloud. And if we unencrypt this data, it basically gives us the output that is produced had it been performed on the unencrypted data originally. And of course, after that, if we enable such services and third-party applications, there would be other consumers of this data, for example, the healthcare services themselves. So here is a summary of SOS. We had multiple high-profile academic publications in various venues. We supervised over 10 master students for their final thesis. We succeeded in acquiring research funding through various applications, including WaspNest, Vinnova, and Horizon Europe. For our contribution to Vinnova Winter, we actually were announced the winner of the competition in the infrastructure track. We also have a commercial service up and running. It's a confidential cloud service that can be used directly. And we also have a spin-off of which we are very proud because it already has 4 full-time employees. And we believe that SOS impacts on stakeholders are kind of broad. Every single citizen can benefit from secure and privacy compliant services. Businesses increases their competitive advantage and revenue in this market, and the society as a whole will benefit from intelligent data analytics in various domains, including digital healthcare and distance education. And here is a list of our publications. And if you have some applications in mind or you think you could benefit from our results and services, please do not hesitate to reach out for more information. Thank you.